Alright, again I'm going to be factoring completely, which means I may have to factor more than once. First thing that I do when I'm factoring is I have to look for a greatest common monomial. I notice that r squared goes into all three of those terms, and 16 and 9 don't share any factors. So that means I can factor out an r squared, and that's the lowest degree of r, so I know it goes into all of them. And so I'm left with 16 r squared minus 24r, because r to the third divided by r squared is r. Likewise, r to the fourth divided by r squared is r squared, plus 9. Well, I have this squared right here, which means I may have to factor this again. So, is there a greatest common monomial that I missed? No. Is this a difference of squares? No, because the difference of squares is normally a binomial with two perfect square terms that we're subtracting, and that's not the case. We have a trinomial, besides we have this addition here. So, could this be a square binomial? And the answer is yes, it could be a square binomial, because my first term is a perfect square, my last term is a perfect square. So I'm going to treat it as a square binomial and then check to see if it's right. A square binomial will have one set of parentheses with a squared, and my a value and my b value. My a value is going to be the first term, the square root of the first term. The square root of 16r squared is 4r. The square root of 9 is 3. And the middle term right here is negative, which means this thing would have to be negative. Now, we know that 2 times my a value times my b value is going to be equal to the linear term. In this case, that's negative 24r. So we have 2 times 4r times negative 3. 2 times 4 is 8. 8 times negative 3 is negative 24r, and it works. Therefore, I know I am done, and I've successfully factored this twice.